Welcome back to our last talk before lunch. I'm very excited to welcome to the stage Jeny, who is a software engineer at Collabora, and who is also an Outreachy alumni of the December 2021 cohort. I'm incredibly excited to be hearing about testing asynchronous applications with FastAPI and PyTest. Jeny, take it away.
Thank you. Good afternoon, all. I'm Jeny, and I'm going to talk about testing asynchronous applications with FastAPI and PyTest today. So before digging into the topic, I would like to briefly introduce myself. So I come from India, and I work as a software engineer in an open source consultancy called Collabora. Before joining Collabora, I was an Outreachy intern. So that's where I started my open source journey. I was working in a kernelCI organization, and I kept contributing to that project while being in Collabora. So now I'm a co-maintainer of one of the projects. If I talk about my technical interest, of course, Python and Linux fascinates me a lot. And apart from that, I love dancing, and I never miss a chance to dance. If the organizers would have given me extra few minutes, you would definitely see me around dancing on the stage. So let's see, these are the agendas of today's talk. I'm going to present what is FastAPI, a brief introduction about what is asynchronous programming. Then we're going to see how to write test for the synchronous code. Then I'm going to present a very interesting test examples from kernelCI-API, that is a backend from kernelCI. So before going into that, I would briefly introduce what the project is about. And then, yeah, we'll see something, some FastAPI in the practice. So, okay, first of all, what is FastAPI? As we all know, Python provides a variety of web frameworks, including Django and Flask. So FastAPI is one of the framework, and what is special thing about it is the statistics in benchmark shows that it is one of the fastest frameworks available. FastAPI supports Python 3.7 version and newer than that. FastAPI is based on Starlet and pydantic. Those are two different packages. So for the people who don't know, Starlet is a package that is specially designed for writing the asynchronous web services. And you can see that FastAPI is a subclass of Starlet. So it directly supports all the features that Starlet provides, for example, WebSocket support, then background task, then events, event handlers like startup and shutdown events. It also has some inbuilt security utilities and dependency injections as well. Now, what is pydantic? Pydantic is a data validation package provided by Python. It works based on type hints. So it has by default validators, and it can be useful to validate your request and response parameters. So it is pretty useful. You don't need to do everything manually. Apart from that, FastAPI provides automatic interactive documentation. It is based on OpenAI, and you can have either Swagger-based documentation or redoc-generated documentation. It is pretty interactive, so you can test your client application from the browser itself. So these were the features of FastAPI. Now we'll see what is asynchronous programming. So programming paradigm can be defined with the two kind of paradigm. One is the synchronous and another one is asynchronous. So when multiple processes are there and all the processes are running sequentially, like one by one, that is called the synchronous programming, right? And when multiple processes are there and they can run at the same time, of course, not like it is not necessary that they are running simultaneously, but if they are running in overlapping manner as well, so you can say that that is asynchronous programming. And what is the special thing about asynchronous programming is it has the ability to wait for a task to complete and do something else in the meantime. So I will explain this in a very simple example. So I have attached two pictures here. The first thing, the first picture shows that a very long queue of the people. So imagine that you are visiting a museum in Adelaide. You have already bought a ticket. Now you are in a queue and you're waiting for your turn to come up to enter the museum. So if you imagine that every single people in the queue is every single process, then they can execute just after the prior one completes. Like for example, if the first person goes in, then the second person goes in. So that is the example of synchronous programming. And while waiting in the queue, they cannot do anything else but just waiting, right? So that is an example of synchronous. Now another picture is about restaurant. So there are multiple tables and multiple group of people are there. If you imagine every single group of people as a separate process, they can order food at the same time. Of course, not simultaneously, but they can do that at the same time. And while waiting for their food to get delivered, they can have a chat with each other or scroll their phone or do anything else they want. So that is the ability of asynchronous code, so that they can do like simultaneous thing while they are waiting for a particular thing to happen. Okay. Now, how to write asynchronous code with a FastAPI. So FastAPI is based on NEIO package. The NEIO package is a tool, or you can say framework, to write asynchronous networking apps. So FastAPI supports that. FastAPI also supports these two backends called Async.io and Trio packages. So you can use any of this package to write your asynchronous code with the FastAPI. Moreover, the modern versions of Python has introduced functions called coroutines. So it is just a fancy word about the asynchronous function. So when you have async and await keywords with your functions, then you can say that this is the asynchronous functions. Here is a pseudocode. So I'm trying to get some documents from my database. So I have defined that function as asynchronous. So I've done that by using this keyword, that is async def. So it will know that this is the asynchronous function. And while the database go and fetches documents from the database, I will wait to get the documents. So I have done that by using the await keyword. So await will wait for the response to get, right? So, and I'm simply returning the documents from the function. So this is a very basic pseudo example of an asynchronous code that you can write for the FastAPI. Now I'm going to discuss like few bullet points about how I write test for the asynchronous code. This is not like official documentation or any standard things, but this is the summary that I find helpful for myself. So first, if you are writing a test case, then you will need a test client. So for the synchronous test cases, it provides a test client called, by default, it has the test client, so you can use for the FastAPI. For the asynchronous, we will be using HTTPX library. That is the another library for HTTP handlers from Python. So you can use asynchronous test client from that library. After that, we will be going to use some of the pytest fixtures. So when you are writing a test case for some kind of specific scenario, that will be case that you will need to have some data fed into your test case. For example, if you need to initialize your application, if you want to set things up, if you want to set your database or any kind of service setup, then you will need those kind of information before you actually run your test. So those kind of functions and utilities you can write as a pytest fixtures, and then you can use it directly from your from a test case. Okay, if I am writing a unit test, if my application has multiple components and multiple modules in my application, so in the unit test, what we do is we just focus on a single separate component and we write test cases for that. If I have application and some of these API services that I'm using, for example, if I'm using database service, Redis service, or any other kind of service, but I just want to focus on a single component API, then if my application is communicating with these other modules, then I need to mock some function calls when I'm writing unit test, because we are just focusing on single module and will be not having those services up and running. So the communication won't be able to happen. So in this kind of scenarios, we need to mock function calls where we require. Then of course actually write your test function, the actual test function. Then you need to define what kind of test environment you would like to run, and then of course run your test. Okay, so I'm going to describe some of the test examples from kernelCI-API. But before that, I would like to introduce this project. This is called kernelCI. So as we all know, Linux kernel is running on a variety of hardwares and devices, right? So it will be very difficult to maintain its stability and quality around this range of hardware. So in 2014, few Linux kernel developers and a few community members from ARM community decided to have a specific CS system for Linux kernel. That's where this project got started, and now it is a Linux Foundation project. So basically, Linux kernelCI is ensuring the quality, stability, and long-term maintenance of Linux kernel. So in simpler words, what you can do with kernelCI is, if you have your specific Linux kernel, then you can build your Linux kernel with kernelCI tools. Then you can have a set of tests on your kernel, and then you can also submit your test to a common database tool, and that will be accessible by publicly. So you can have your test reports, regression reports, even bisection reports with kernelCI. If you are more interested, then I have mentioned a link there, kernelci.org. You can go and check out the project in detail. And the reason I'm discussing kernelCI here is kernelCI has a new backend called kernelCI-API. And kernelCI-API is based on these major building blocks. It is built on top of FastAPI. So that was the reason I'm discussing this project. For the database, it uses MongoDB, and Redis is an in-memory database. And it also has a storage support. You can use SSH for the upload and HTTP for download. So that I'm not going into detail because this is out of scope for this talk. But everything is up publicly on GitHub. If you want to access this project, you can go on this GitHub link and find the kernelCI-API project. Now let's dig into the test examples. So first I am going to describe the unit test example. So API has a root handler. A root handler, of course, we all know that it is the entry point or initialization point for any application. So in case of kernelCI-API, it returns this dictionary with a message as a queue, and kernelCI-API as a value. It is a pretty basic endpoint, the root handler one. So if you send the HTTP GET request to this root endpoint, it will be providing this response. Now, how to write test of this kind of endpoint? So as we saw that we need to have some kind of test client to write the test for it. So I have used FastAPI.test client package to use the synchronous test client. So if you see, the first frame I have shown in the snapshot is I am creating an instance of that test client. It will need two arguments. One is your application instance, and another one is the URL of your API server. So in the unit test, we are not going to run any kind of server, the actual server. So what we can do is we can use the demo server or fake server provided by FastAPI. So this is the default server, that is HTTP test server, and I'm going to use it in my test case. Please note that I have written it as a form of pytest fixture, because test client is something that will be needed to fed with every test cases that I write. Okay, so I would need that for the initialization. So I have chosen it to be as a pytest fixture. And another function is test root endpoint. This is the actual test case of my unit test. So what I'm doing is I'm passing the test client, the fixture name in the argument. So that is the way of using pytest fixture. You just need to pass it in the argument, and it will be executed before actual test case executes. So what I'm doing is I am sending HTTP GET request using that test client with test client.get method, and I'll be receiving some HTTP response. We can use some asset statements to verify what your test has received as a response. So you can, I have used this asset, the last frame of the snapshot, that asset response.status code equal to 200. So if this condition fails, it will raise the assertion error, and my test will fail. Okay, so let's try to run a test. Of course, there are a variety of testing environments that you can use, but I have chosen the very basic one, and this is the command line utility. So I'm running pytest commands on the command line to run my test. So let's see how it goes. Oh, and the test got failed. Why? So in the snapshot, I have shared that these are the error logs that I've received, and it shows that there is some kind of startup handler is there, and it is trying to connect one method called pubsub.create, and again the last line of the frame shows that it is trying to connect with some method called pubsub.initSubID. So under the hood, what happened is, now API has publisher subscriber mechanism implemented. So it is using some kind of tool called Redis. So Redis is an in-memory database tool. So you can use it for your PubSub mechanisms. So under the hood, kernelCI-API is trying to connect with the Redis server on its initialization, but it is not trying to connect. Like, it is trying to connect, but it got failed. Of course, this is the expected outcome because we are not running any Redis server with our test, right? So how do you deal with this kind of situation? So I've also mentioned that you can mock function calls whenever you need it. So what you'll do is, you'll have a mock function call to your method called pubsub.initSubID. So there is a package called unit test from the Python. And if you are writing test for the asynchronous functions and you want to mock that function call, you can use this specific async mock from the unit test package. Okay, and the first frame I have drawn here is, it has created one async mock object, and the another line says that mocker.patch, it is used to patch your class level methods or even modules to patch that particular function with the mock object that you have created. So with the async mock, I have mocked the function call that is pubsub.initID. So what now will happen is, when the pubsub.initSubID method gets called, instead of calling that specific method, it will go straight to the asynchronous mock object. So nothing will break in this case. So I have defined this as a pytest fixture as well. So I am passing the name of the fixture in my test case, that is test root endpoint, and I'm passing that function name. So so whenever it tries to connect the pubsub method, it will go to the asynchronous mock instead, right? And then the rest is same. I have not updated anything in that code. So let's try to run this test again. So now, yes, it passed. So we have used pytest fixtures, and we also tried to mock some function calls with this test. So that was the example of unit test. Now let's see an example of end-to-end test. So before that, let's see what is end-to-end test is. For the unit test, we were trying to test a single component or single module at the same time. But for the end-to-end test, when you are testing your software application from a specific workflow from the start to end, so that is called the end-to-end testing. For the end-to-end testing, you need to have a well-defined workflow before you can test it. So I have demonstrated a very minimal pipeline here. So I've already said that kernelCI-API has publisher subscriber mechanism in place. So I'm going to try and use that interface to test my whole pipeline here. So what I'm going to try here is, I will be writing a subscriber mechanism, and that will be subscribed to a specific channel called the user channel. So the user channel will receive all kinds of events when user accounts will be created or updated or even removed. So these kind of messages will be broadcasted on this channel. So we'll be subscribing to that channel, then we'll be listening on that channel. Rather, I'd say that we'll be polling on that channel to receive the continuous events. So that will be in the infinite loop. And meanwhile, a user account will be created. So what I expect is, when a user account gets created, the created event should be broadcasted that channel, and the subscriber should receive it, right? So we'll check if that happens or not. And at the end of the workflow, I'm going to unsubscribe the channel. Okay. So how do we write test cases for it? As this is the pipeline that I've shown, it is completely asynchronous. All the functions of that pipeline is going to be asynchronous, and that's why we need to use the synchronous test client for it. So the HTTPX library provides the asynchronous test client, and we are going to use it. So I have defined another pytest fixtures that is called test async client. And what I'm doing is I'm creating an instance of that asynchronous test client. So it is same as we did for the synchronous test. The difference is instead of using the fake test server URL as your base URL, you'll be needing an actual API server URL. For example, if my API is running on this URL called HTTP API, port is 8000 and the version prefix is latest. So if my API is running on this particular server URL, then I will need to use that for my asynchronous test client, because at the end I'm going to run my API server and it will be trying to connect to that actual API server. So that is the difference between synchronous and asynchronous test. The next thing is we will be subscribing to a channel called user. So API has an endpoint defined to do so. So what I'm doing is I am defining a test function called test subscribe. I'm using the fixture for the testing asynchronous client. So I have passed the fixture name in the argument, that is test async client. And please note the first frame of the snapshot that I have used two decorators here. So first one is pytest.mark.async decorator. So if you are writing a test for some kind of asynchronous function, then you need to then you need to let the pytest know that this is a synchronous test and not synchronous test. So you can do that by using this decorator called pytest.mark.async. Another one is pytest.mark.order decorator. So when you have multiple tests and you are testing for a specific pipeline or a workflow, you will need that some kind of test function should be executed at the very beginning of your flow. For example, if subscription is not going to happen, we are not going to unsubscribe anything, right? So we need that this test subscribe function should be executed at the very beginning. So I have marked order and I'm passing the value 1. So it is the way of saying that this test should be executed first. And what I'm doing in the test case, the test subscribe test is, I'm sending the HTTP post request to this endpoint, subscribe/user endpoint. And what I'm receiving is, I'm receiving a subscription ID as HTTP response. So now see the last frame of the snapshot. That pytest has a way of sharing global variables. So if I need some kind of information and that should be shared among all the modules or all the test cases, then I can use the pytest global variables. And this is the way of defining it. So if I write pytest.subscription ID, so that subscription ID variable will be accessible through all your test cases. So now we are going to listen to that subscription ID. As I've already said, listening is a kind of in an infinite loop. So it should be run as a background task rather than a traditional asynchronous test function, right? So a way of doing is there is a package called Async.io, and it provides something called task objects. So you can use that to create your task that should be run in the background. So here I'm going to listen on that subscription ID, and I'm going to create that task for that would be run in the background task. So this is the way of defining a background task in your asynchronous code. So I have used async.io.create method, and I'm passing the endpoint HTTP get endpoint to that handler. So it will return me the task handler, and from the time to time I can also track the status of that handler. So now this is the main function of this whole workflow. I've defined a test case called test pipeline, and please note that this uses the decorator called pytest.mark.dependency. So what it means is this: if some kind of test cases depends on a variety of test cases, you can define the dependency like this. So it shows that this test function depends on test subscribe. So if the test subscribe gets failed or anything happened to that test case, this test case will simply be skipped. So that is the utility of depends decorator. Now in the test function, I am creating one listen task. So I'm polling for the different kind of listen events by using this task handler, and it is returning task listen task. And meanwhile, what I'm doing is I'm creating a user account. So I'm sending HTTP post request to the user handler, and I'm passing very basic information, that is username and password, to just create a user account. So what I expect is the task listener should receive an event that a user account has been created. So if the status has been updated for the task handler, I can get that status using the await keyword. So what I've done is I've used await and then my task handler. So if I get the event data from my task handler, and I also can verify my event data, that if I intend to receive the user creation event, then I should have received it, right? So I've used a bunch of async statements to verify that. So I have that event data should have like two parameters. One is the operation and another one is the ID. So it shows me that operation is created, it means user account has been created. And ID will show that what is the ID of the user account that has just been created. So you can use bunch of async statement to verify that cloud event as well. And at the end of the flow, I'm unsubscribing to the channel. So I have used another decorator called pytest.mark.order, and I've passed value last. So when you want some function to be executed at the very end of your flow, then you can do that by providing last as a value to your pytest order decorator. So I've done it. So unsubscribe is something that will be executed at the very end of the flow. And now we have the actual test function called test unsubscribe. And what I'm doing is I'm just sending HTTP post request to the unsubscribe endpoint. And again, I'm using that pytest or subscription ID variable here. So I have shared that variable among all the test cases, and I've used at so many places. So that is the reason that I have declared it as a global variable. And at the end, I'm just verifying that if the HTTP response code is 200 or not. So that was all the test cases of end-to-end test. Now it's time to run all the tests. So for this, I need to actually run my API server, and then I would need to run my Redis server as well, because for the publisher subscriber mechanism, I have used a Redis server. So I've done that. And after starting all the servers, as I'm running the test from the terminal itself. So it shows that all the test cases that I have run from my end-to-end test. So you can see that test subscribe executed at the very beginning, because I passed the order value as 1 for that test case. And another one is the test pipeline. And at the end, it runs the test unsubscribe method. So the pytest function also gives you the status, and it also shows the time duration that it took to run your all test. So because of the time constraint, I just could explain two test cases, that is unit test and end-to-end test. If you're interested, and if you want to check some of the more examples from the kernelCI-API, that I have put the GitHub link, and you can go and check that. So that was all from me. Thank you so much.
Thank you very much. Here is a small gift as a thank you for giving a session.
Thank you.
And for attendees that haven't been able to see this, it is a mug with this year's 2023 artwork on it. So it's the exclusive speaker mug. Congratulations. Thank you.
Thank you so much.
We